Hi, my name is Prabhjeevan Kalra, and my topic is resting potentials and action potentials. This video is being made for biopsychology at Laurier University. Potentials. All potentials result from ions moving across membranes. Two forces on ions: diffusion, which is from high concentration to low concentrations, and electrical, toward opposite charge and away from like charge. Now we're going to be talking about the overview of a nerve impulse. Number 1, resting potential. Neuron is not stimulated at threshold level. The neuron is at rest. Number 2 is action potential. Neuron responds to stimulus and sends a message along the axon. Action potential basically is communication between two neurons. There's two steps: depolarization and polarization. And potential means that there's difference in charge. It's measured in volts. Now we're going to be talking about resting potential. Resting potential is neuron when it is inactive, meaning it hasn't reached threshold. Inside the cell, there's more potassium ions, and outside the cell, there's more sodium ions, as you'll see in the next picture. And this is polarized cell membrane. Inside the cell membrane, it's a negative charge, and outside the cell membrane, it's a positive charge. Cell membrane relatively impermeable to both ions. So both ions are constantly moving in and out through leaking. This is a picture showing that there's more concentration of sodium outside the membrane and a higher concentration of potassium inside the membrane. Resting potential results from passive potassium channels. At rest, membrane potential is negative 60 to negative 70 millivolts. This is at rest. And why? It's because potassium is most permeable due to the leak of potassium through passive potassium channels. For potassium ions leave, making the inside more negative. Now we're going to be talking about action potentials. Only neurons and muscles have action potential. Well, most neurons do. This is because due to the voltage gated sodium channels. Most in axon. An initial segment is the axon hillock, and nodes are Ranvier. There's a few action potentials in big dendrites, not small. Action potential, which also equals a nerve impulse, is critical. Is only occurs when it reaches threshold. It's an all or none response, and it's a positive feedback system. It passes through one neuron to another, and it only occurs if it reaches a minimum level, which is a threshold. It either occurs or it doesn't occur at all, and it only lasts a few milliseconds. And there's two steps, as we before: depolarization and polarization. Depolarization. What happens? The stimulus causes adjacent sodium ion channels to open along the axon. The sodium ions rush into the cell from high concentration to low concentration. Movement of sodium ions reverses the charge of the membrane, which causes depolarization, meaning it's going from negative 70 millivolts to a number that is higher than that as a positive value. Inside cell membrane, it's a positive charge, and outside the cell membrane is a negative charge. If threshold is reached, adjacent sodium ion channels to open along the axon. Now we're going to be talking about the repolarization phase. In the repolarization phase, potassium ion channels open and potassium ion channels rush out of the cell from high concentration to low concentration again. This is through diffusion. And restores polarization of the cell membrane. Inside the cell membrane becomes a negative charge, and outside the cell membrane becomes a positive charge. Repolarization is coming from a higher value to back to the negative 70 at the resting value. Ion distribution is different than resting potential and can't send another impulse yet. This is called as the refractory period. Inside cell is low potassium concentration and high sodium, and outside is high potassium and low sodium, as you could see on the graph. Now we're going to be talking about after the repolarization phase. Sodium and potassium pump corrects the ion distribution, and inside the cell becomes high potassium and low sodium, and outside the cell is low potassium and high sodium. Another impulse can now occur. And the role of myelin during an action potential. Myelin covers the axons and it insulates it, and action potential must jump from node to node. This is known as saltatory conduction, and action potential is much faster in myelinated axon than in long and unmyelinated axon. Thank you, and I hope you enjoyed this presentation.